So we're going to review these derivatives that we did in class because of the mistake that I made. So we know this this integral, not derivative, this integral, 1 over 1 minus x squared dx, we know that equals arcsine of x plus c, but we don't know what to do when this constant is a 9. So we need to do some manipulation to turn this constant into a 1. So what we want to say is x equals 3u. So usually, you know, which means, of course, that u equals x over 3. Okay, and then when we differentiate, we get dx equals 3 du. And now we're going to do the substitution that we always do. So x is 3u, so x squared is going to be 9u squared. Dx is just 3 du, so we're going to get a 3 and a du. And then we can bring the 3 outside. So we get 1 over 3, 1 minus u squared du, and then these 3's cancel out. And now we just have an integral that we know. And this equals arcsine of u. And here's the mistake that I made. U is x over 3. So it's arcsine of x over 3 plus c. So let's just do this in general. So if we have 1 over square root of a squared minus x squared dx, then we choose x equal to a times u, and dx equals a du, and u equals x over a. And then when we do our substitution, we get 1 over square root a squared minus a u squared du. We get an a out here. Get a. We can take out the a. 1 minus u squared du. A's cancel. Arcsine of u plus c. And that's arcsine of x over a plus c. Now let's do the same thing with arctan in general. So if we have 1 over a squared plus x squared dx, we do the same thing. We do x equals au, u equals x over a, dx equals a du. There it goes. Okay, so we have a, 1 over a squared plus au squared, and then when we factor out the a squared, we have 1 plus u squared, and we still have the a there on the outside. But now we still have a 1 over a left over. And now it's arctan, like we know how to do. Right? So then it's arctan of u times 1 over a plus c, or 1 over a arctan of x over a plus c. So those are the general integrals which you can use.